Hello everyone, today let us solve one more numerical. The numerical goes like this. During a storm, a car traveling on a level horizontal road comes upon a bridge that has washed out. The driver must get to the other side, so he decides to try leaping the river with his car. The side of the road the car is on is 21.3 meters above the river, while the opposite side is only 1.8 meters above the river. The river itself is raging torrent 48 meters wide. So we have to calculate how far should the car be traveling at the time it leaves the road in order just to clear the river and land safely on the opposite side. And the second point, what we have to do, what is the speed of the car just before it lands on the other side. So let us solve this one. So what exactly is given? There is a river on which the bridge is washed out because of floods something. So let us say this is the river and here is the water below the one. Above the river level at certain height our car is here. So our car is in this place and this wants to go to the other side. But this side is at a height of 21.3 meters above the river, but the other side is only 1.8 meters above the river level. Now what this car driver wants to do, he wants to jump from here to here. That is what he wants to do. So the question is, how fast should be the car when it wants to jump the road? And what is the speed of the car just before it lands on the other side? So that is the question. Let us see what is the data given. One side it is 21.3 meters height and the other side it is 1.8 meters height. Therefore, the difference in the height let us take as the vertical displacement. Delta y is equal to y1 minus y2, that is equal to 21.3 minus 1.8, that comes around 19.5 meters. So in the vertical direction we have g, that is acceleration due to gravity, which is 9.8 meters per second square. Then let us take the equation. S is equal to ut plus half gt square. Then substituting these values, delta y is equal to 0 into t plus half into 9.8 into t square. So what is delta y? Delta y is the difference which we got just now as 19.5. So 19.5 is equal to half into 9.8 into t square. Therefore, t square is equal to 19.5 into 2, 19.5 into 2 divided by 9.8. So that is the value. That is equal to 19.5 into 2 by 9.8. Therefore, t is equal to approximately you will get 1.994 seconds. You can take it as 2 seconds. So t is equal to 2 seconds. So this is the time taken for the car to go from this side to that side. Therefore, let us find the speed now. Let us take the speed. In the horizontal direction, there is no change in the speed. It is going with a constant speed. Therefore, we want to calculate the speed, that is speed along a horizontal direction. Vx is equal to distance upon time. Distance means the width of the river. Width of the river is given in the problem as 48 meters. 48 meters divided by 2. So it comes around 24 meters per second. 24 meters per second. So this is the speed with which the car jumps when it is going from left side to the right side in our figure. Then after that we want to find the speed, that is Vy. Vy means vertical speed when it lands onto the other side. So let us go for that. Since the car is moving with a constant speed, therefore the initial and final velocity remains. So the final velocity of the car in horizontal direction, we got 24 meters per second. Already we got that. Now we want to find the velocity of the car in the vertical direction just before landing. That can be calculated using our kinematic equations. V is equal to U plus GT you can use. Therefore, substituting the above values, we can get V, that is in vertical direction, is equal to U in the vertical direction plus G into T. Then V in the vertical direction is equal to initial velocity in the vertical direction is 0 plus 9.8 into T, that is 2. So that comes around 19.6 meters per second. This is the component of velocity, that is the vertical component of velocity. Therefore, we want to know the final velocity with which the car lands on the other side. That is, we have to take, that is V final is equal to under root Vx square plus Vy square. Therefore, Vx square is the same like initial and final, which we got earlier. That value we got as 24 square. 24 we got. I'll take you up and show you. This is what we got here. This is the Vx value, and Vx is not changing in this horizontal direction. Therefore, it remains the same. Therefore, Vx is 24 meters per second, and Vy we got here, this is 19.6 meters per second. Therefore, let us use both of these values. That is, Vx square is 24 square and Vy square means 19.6 square. And Vx square is 24 square and Vy square is 19.6 square. So it comes around root 960.16. Then once you find the root, approximately you will get 30.98 meters per second. So roughly you can take it as 31 meters per second. So this is the velocity with which the car reaches the other side and it lands on the other side. That is, when the car jumps to the other side, the speed of the car on the other side is 31 meters per second. So this is the solution of the problem. Let us meet with another numerical problem in the next video. Bye. God bless you all.